This series of videos will be on section 4.3 in college algebra and context, one-to-one and inverse functions. The functions f and g, for which f of g of x equals x for all x in the domain of g, and g of f of x equals x for all x in the domain of f, are called inverse functions. In this case, we denote g as f inverse. Right, we read that as f inverse. An important note, in f inverse and g inverse, the -1 is not an exponent. It denotes the inverse of a function, just as f and g are not variables. These are not in exponents. The function that can be used to convert the temperature in degrees Celsius to degrees Fahrenheit is given by f of x equals 9/5 of x plus 32, and the function used to convert degrees Fahrenheit back to Celsius is c of x equals 5x minus 160 over 9. To see how these two conversion formulas for temperature are related, we're going to find c of f of x and f of c of x and determine if the functions are inverse functions. So first, finding c of f of x. That means we're going to start with this big C, and in place of the x, we're going to put f of x. So c of f of x would be 5 times 9/5 x plus 32 minus 160, all divided by 9. Well, 9 times 9/5 will be 9x. 9 times 32 is 160 minus 160, all over 9. 160 minus 160 will be 9x over 9, and we find that c of f of x equals x. Now we want to find f of c of x. So we'll start with f of x, 9/5 times 5x minus 160 over 9 plus 32. Well, these 9's will cancel out, and we'll end up with 5x minus 160 divided by 5 plus 32. Well, we can divide here, and we'll find out x, and divide here, minus 32 plus 32. So now we found out that f of c of x also equals x. That means because this worked both ways, and it has to work both ways, these are inverse functions. So yes, they are inverse functions. Function f is a one-to-one function if each output of the function corresponds to exactly one point in the domain of the function. This means there's a one-to-one correspondence between elements of the domain and elements of the range. We know to make it a function for each x, there's only one y. To make it a one-to-one function, also for each y, there's only one x. We're going to look at a couple different ways to determine this. First, I'm going to start with a equaling 2 and b equaling -2 for this function f of x, 5 times x to the 4th. Well, f of a then is 5 times 2 to the 4th, or 5 times 16, which equals 80. So f of a equals 80. If I find f of b here, so I'll have 5 times -2 to the 4th. I put the 4 on the outside this time because we are raising the negative to the exponent. That ends up equaling 5 times 16 again. So f of b equals 80. We started with 2 different values for x and ended up with the same answer. So this is not 1 to 1. I'm going to start out and say A does not equal B, and I'm not even going to designate the numbers. I'm just going to say whatever they are. Well, that means A to the 5th would not equal B to the 5th. Because these are 5th powers, the odd exponents, that makes a difference. Now I'm going to subtract 2 from each side. So A to the 5th minus 2 does not equal B to the 5th minus 2. So if we started with different values, we end up with different values. So this is yes. This is 1 to 1. For a test to be 1 to 1, no horizontal line can intersect the graph of the function more than one point. We already know what the vertical line test makes it a function. Now we also have a horizontal line test. Determine if each of these is 1 to 1 by using the horizontal line test. We have the same 2 functions we just dealt with, and here they are graph. So 5 to the 4th, 5 times x to the 4th, you can see here's the graph. It does not pass the horizontal line test. It is not 1 to 1, as we already knew. This is the graph of y equals x to the 5th minus 2. It would pass the horizontal line test, and it may be a little deceptive here. It would pass the horizontal line test. It may be a little deceptive here because you might think that this is straight across and it crosses several times. But if we enlarge that point when x is -2, you would find out it had a slight slant to it. A very tiny one, but it's there. The functions f and g are inverse functions if, whenever the pair AB satisfies y equals f of x, the pair BA satisfies y equals g of x. So notice, if they're inverse functions, we can just switch or invert the x and y values. Note, when this happens, f of g of x equals x and g of f of x equals x for all x in the domain of f of g respectively. The domain of f is the range of its inverse, g, and the domain of g is the range of the inverse, f. This is an important thing. We want to determine if f of x to the 5th minus 1 is an inverse function. Well, we already know from work we just did that we had g of x equals x to the 5th minus 2. This would only say 1. So is this a 1-to-1 function? And if we graph it, if I get a quick graph, and this was -1 down here, it would look like that. So does it have an inverse function? Yes, because it is 1 to 1.